This is our AP Calculus prep session, and this is my free response problem 1 in our differentiation techniques section. And we'll just go over these. Let f be the function defined by f of x equals the natural logarithm of quantity 2 plus sine x for x is greater than or equal to pi, but less than or equal to 2 pi. Find the absolute maximum value and absolute minimum value of f. Show the analysis that leads to your conclusion. Well, this show we can demonstrate using what's called a candidate test. And a candidate test is we take certain input values and we evaluate all those input values to see which ones are an absolute, amongst them, the absolute maximum or minimum. Well, a candidate test, I'm going to go ahead, it usually manifests itself, or can manifest itself as a table. Just put it in simple organizing form. And so we have input of x, and on the right side we have f of x, which is our output for given x. And in the candidate test, the first candidates we're going to talk about here are what are called the endpoints. And the endpoints would be these values that frame our interval, the lowest value being pi, and the greatest value being 2 pi. And so here I go ahead and demonstrate this is what these are the endpoints. Okay, now next we're going to look for critical numbers, and to find critical numbers we need to take the first derivative of the function here, and for a natural logarithm a first derivative is equal to the derivative, in this case quantity 2 plus sine x, over the original. And the derivative of 2 plus sine x, the derivative of 2 is 0 of course, and the derivative of sine x is going to be cosine x. And then we have, in the denominator here, we have 2 plus sine x. Now, we should know that our value is going to be, our critical numbers are going to be wherever the function is undefined or 0 more commonly. And 2 plus sine x is never going to be equal to 0 in that interval. So we only know that our numerator, cosine x, we can set equal to 0 and solve for that. Well, the only place that cosine x is equal to 0 in this interval, from closed interval from pi to 2 pi, is going to be at 3 pi over 2, or along the y-axis. So we'll say on the closed interval from pi to 2 pi, okay, x is equal to 3 pi over 2. So this is another value that has to be considered. So I'm going to come right over here and put in 3 pi over 2. And then we're just going to evaluate what all these are. Well, for the original function, I'm just going to write these values here. F of pi is equal to the natural logarithm of 2 plus sine of pi. Well, the sine of pi is 0, and so we're going to be left with simply the natural logarithm of 2. Okay. Next, f of 2 pi is going to be equal to the natural logarithm of 2 plus the sine of 2 pi. Well, just like the sine of pi, the sine of 2 pi is 0. So again, we have the natural logarithm of 2. So here at the endpoints, we have natural logarithm of 2 and natural logarithm of 2 as outputs. Next, what we need to do is find for the critical number, we're going to need to find which is 3 pi over 2. So f of 3 pi over 2 is equal to the natural logarithm of 2 plus sine of 3 pi over 2. Okay, and the sine of 3 pi over 2 is going to be -1. Okay, so that's going to be the natural logarithm of 2 minus 1, which is the natural logarithm of 1, which equals 0. So 0 is this other value we put here. And so we just say absolute minimum equals 0, and absolute maximum is equal to the natural logarithm of 2. So really, that's it for that one. We need to go ahead and work out part B. Find the x-coordinate of each point of inflection on the graph of f. Justify your answer. Well, for this, if we find the high and the low and the derivative, we're going to use what's called the quotient rule. And so we're going to take the second derivative of this original function, which is the first derivative of f prime. So our high, purple here, our high value is going to be equal to cosine x. Our derivative, which I'm going to call d high of cosine x, is going to be negative sine x. Our low is going to be 2 plus sine x. And our derivative of our low is going to be equal to the first derivative of 2 plus sine x, which is cosine x. And so f double prime, which we're going to use to find the inflection point, points of inflection, is going to be equal to low, and low is 2 plus sine x times the derivative of high, which is negative sine x, okay, so minus our high, which is cosine x, times the derivative of the low, which is also cosine x. And that's going to be all over this quantity 2 plus sine x squared. So really, we're going to set this numerator equal to 0 to find the points of inflection. So we're going to say 0 is equal to, we have negative sine x times 2, so we're going to have negative 2 sine x. We're going to have negative sine x times sine x, which is going to be minus sine squared x And then here we're going to have minus cosine times cosine, which could be minus cosine squared x. And really, we can kind of work this out a little differently if we, there's the identity that sine squared x plus cosine squared x is equal to 1. And so that could help if we can arrange to use that. So if we have negative 2 sine x, and we're going to have minus quantity sine squared x plus cosine squared x. And this sine squared x plus cosine squared x can be replaced by 1. So we're going to have 0 equals negative 2 sine x minus 1. So if we just solve this for 0, we'll be able to figure out what we have here. So I'm going to bring this up to the right to continue working below. And working below, we have, we're going to add 1 to both sides of this equation. So we have 1 is equal to negative 2 sine x. And dividing by negative 2, we're going to have negative 1/2 equals sine x. Well, on the interval from negative 2, from pi to 2 pi, we do have a sine value of negative 1/2 there. And x is going to have to be equal to 7 pi over 6. And also x is going to be equal to 11 pi over 6. So these would be our critical numbers. So we will go ahead and make an analysis of this. To do that, I'm just going to make a number line and label on that number line 7 pi over 6 and 11 pi over 6. We're going to consider above the number line will be f double prime and below will be f. And it can be a little challenging to find out what these between pi and 7 pi over 6. We're going to go right between 7 pi over 6 and 11 pi over 6 at 3 pi over 2, right between the two. And what we're going to have is we're going to see if that's positive or negative. So here we have 0 equals negative sine x minus 1. So if we plug in 3 pi over 2, we're going to get negative 2 times negative 1, and negative 2 times negative 1 is 2. 2 minus 1 will have positive here. So we are going to be concave up on the interval from 7 pi over 6 to 11 pi over 6. And because we just have a multiplicity of 1 of these critical numbers, we know we're going to be concave down in the remaining intervals. So we see that we have points of inflection. So we have points of inflection at 7 pi over 6 and 11 pi over 6. Go here. Trying to make this legible if I can. And 11 pi over 6. And why? Because f double prime changes from positive to negative, or from negative to positive. I've seen it listed as changing signs also. Anyway, this is the problem. It's a nice little problem. I think the way, coming from the AP test, I think this entitles you to probably about 7 or 8 points if you do just this. Good luck, and thanks for viewing.